Hi everyone, I hope you are doing good. So today in this advanced C++ series, we will take a new topic, that is variadic templates. In last video, we have discussed about the variadic functions, like C-style variadic functions, where we have used the varist, va start, va arg, and va end, right? So, and there we have seen some limitations of the variadic functions. To overcome those limitations, C++ came with a new feature, that is variadic templates, that which we are going to discuss today in detail with the multiple examples. So in this session, we will cover the need of variadic templates that I have just said, like to overcome the limitations of the variadic function. And then we will see how can we make use of the variadic template, how can we create, how can we call, right? How it works internally, that also we will see with the help of the assembly files and some intermediate readable files that I will generate and show you. And then what are the arguments the variadic function supports, variadic template supports, because we have seen some limitations with the variadic functions, right? And all these things we will cover in detail, so please watch the video till end so that you get to know about each and every usage and aspects of the variadic function, variadic templates basically, correct? So let's start with the variadic function first. So let me show you quickly, because in last video I have discussed in detail that variadic functions, or you can say C-style variadic functions, right? Because it comes with C also. Here in C++, how we do that? So basically, variadic means variable number of either you can say templated arguments or arguments, right? So a function which takes variable number of arguments or arbitrary number of arguments, that is the variadic function, right? So here this function, this print number function, may take at least one and at least one argument, right? Or you can say more than one. Any number of arguments you can pass to these functions and it will work fine. This is why it is called variadic, right? It means it can take arbitrary number of arguments, right? So here first it will get the count, and then here we can pass the like count is 2, then we can pass 2 plus 2 arguments, that is 3 total, right? I'll show you the call of this one also. So here in main, this one, right, print number. So here I am saying 2, right? 2 is the count, and then 2 arguments, right? 2, here I am passing integer 2 and then 2 arguments. It means the total number of arguments is 3. Now here I can pass, I can make another call also, that is what I have discussed, right? So for example here like this, here I can pass 3, right? And here I can pass one more arguments, uh, 12 integer, that is fine, right? So here, so now this is, here we are passing 4 parameters, right? So first will, so you have to remember, first will be as a count, will be passed as a count, and then that number of arguments we will pass. So total would be plus 1, right? So here 3 plus 1, that is 4. So here this function will be called right, this one. So here the count will be stored in count, and then the variadic list. And for this we have what we saw, that we first have to create a variable list, right, to store the variadic arguments, right? So this is a VA list provided by C stdarg, this header file, right? And once we have declared this list, right, then we have to initialize that list. That is what we have seen in last video, right, using the VA start. So in VA start, what we are passing first, this list and the count, right? Count we are, which we are getting from the call, function call, right? So this count, for example, 2, in that case, this ARGS list, it will be initialized with two arguments. If we are getting it 3, count is 3, then this ARGS will be getting initialized with 3 arguments, right? That is what the usage of the VA start. Now we have the argument list with initialized, right? It is initialized now here. Now what we will do, we will basically fetch these numbers, not numbers, basically these arguments, right? It could be number or it could be string, whatever, right? From the arguments, right, using the varg. So this macro, it is provided by the stdarg, right? So here the limitation was we have to basically provide the data type. then only we get it, the basically respective argument, right? So the programmer must know before fetching any argument the type of that argument. So this was the limitation with this one, right? So here, for example, integer. So we are fetching integer here in number. Then second, its character pointer, right? So that will be fetched by VARG here, right? And here, if we have another integer, so in this case, so in that case, the third one, so then we have to fetch the integer also again, right? So this was the limitations, like we have to know, the programmer must know the data type for which it is basically making the call of VARG. So this was the variadic functions. Now the limitations of this one we have seen, like one is I have explained here, the data type we should know, right? And it does not support the custom data types also, correct? And the third one is we have to pass the count here, right? And that count is used to initialize. So this is the under limitation, right? So to overcome all these limitations, C++ came with a new feature, right? And that is variadic templates. So now here variadic, you understand, it means variable number, arbitrary number of arguments, right? Template, it means templated arguments. So now here in variadic functions we are not using any template, right? This is simple function. But now in variadic template we will use the variadic also plus template also. It means it would be a templated functions which will take arbitrary number of arguments, or you can say variable number of arguments, right? I hope it is clear. Now coming to the how can we basically declare or define the variadic templates. So in variadic templates we have to use the recursion, right? And you know that for recursion there will be a base condition also, right, to basically stop the recursion calls, right, to terminate the recursive calls. So for that what we have, this is the base condition, right? It could here I have added a function print which is taking one argument, one templated argument basically, right? And it is doing nothing, it is basically not calling anything. But here this is my recursive functions, or you can say this is main variadic template functions, right? Here what it is happening, uh, here it will take two arguments. One will be the type of t template, and other will be a list, right? So this would be a list, you can say, right? And here in template also you will see type name, right? Then t. So one templated parameter is one t, and other one is type name, then dot dot dot. Three dots you have to use here, right? In variadic functions also we are using three dots to basically uh, catch the variadic list, right? And here also we are doing same, right? Three dots and then the templated argument name. It could be anything, right? So here this templated argument name args. Now in function signature, what we have to do, first we have declared one t of t type, right? And other list that is args, right? So this is my basically argument name, and this is my templated argument name, right? And you know that how can we use the template, so that is what we are basically applying here, right? And if you have any difficulty in templates also, then I have already created one video, separate dedicated video for templates. There I have used multiple examples, so you can go and watch that also, right? So now here you see that one variable is t and other one is args. Args is a list, right? And I can directly make use of t here because t is a separate variable now, and args is a list. So what I will do to fetch the another numbers, right? So I will directly or I will recursively call the print itself. And here how I will call print and then args, and then I will pass the three dots dot dot dot, and just after the args variable or that list variable, right? Here in variadic function we are creating one list, va list, right? And here we are initializing using va start, where we were giving the count and this list variable. Similarly here it will be initialized automatically here itself by the compiler, and so there is no need to initialize it separately, right? And here when we do this call args dot dot dot, it means the first number or the first argument will go to the this one, right? And the rest of the arguments will go to the this list again. How it is getting called? The first one, when we call this one, when we make this call, then the first argument will go to T here, right? And because this is also a templated one, right? So there is no need to make sure about the types, right? So here in variadic functions, we have to give the type also, and then only we can access or we can fetch the variable using the varg. But here, as it is a templated one, and template is, it means generic one, right? So that is why we do not have to pass any type or anything, right? So what it will do, the compiler will do, the compiler will first argument, it will map with this t variable, right? And the rest of the list will go to the args here again, correct? And likewise, once we have only one argument in this list, in that case this call will be called and this recursive call will get terminated. I hope it is clear. Don't worry, I will show you the assembly code also, and I will generate the dump file also. There I will show you how it is getting expanded. So, and you know that in templates, right? Templates get expanded at the compile time only, right? I have explained. Explained this thing in the this templated session also, right, with multiple examples. So here also I will show you the assembly file and the dump file. There you will see multiple definitions, right, according to the argument list. How I am making call of this one from the main. So here this is print, right? Here you will see one difference here. So in print number, that is the variadic function, C-style variadic function, right? Here what we are doing, we are passing the count and then two arguments, right? And here we are not passing any count. See here I am one. Then so these all are the arguments. So here also these are the arguments. Count is also argument, but you have to pass this count, right? So that it can, this variadic list can be initialized, right? Here we are making use of the count, right? But here we are not passing any count. We are directly passing the list of the arguments, and here we are passing 4. And here you will see we are not explicitly doing any initialization. We are not using any data type, right? All is taken care by the compiler itself, because of the templates here, right? And that is why it is called variadic templates. It means that there would be a templated function which is taking arbitrary number of arguments. So let me build this one. So here this a.exe got created. Let me run this one. So I am using the G++ compiler. So here you see 42 and hello. So this 42 and hello is getting printed from print numbers, right? Here first number is 42 from here, and the second is character pointer, so that is hello. It is coming into word from the here. So here we are passing integer and character pointer, right? And the 2 that we are passing, that is this 2 is getting used to initialize the argument list. I hope it is clear. And now coming to the variadic templates here. So here first we are passing these 4 arguments, right? And these 4 arguments will be first, this function will get called with 4 arguments. First will go to this, and args will have the 3 arguments, right? So first will be printed here, right? And that is 1. So this 1 is getting printed. Now again with 3 arguments, this print will call again itself recursively. So first argument will go to T, and the rest 2 arguments will go to args list, right? So here this T will be printed here. The second one, that is 2.5. 2.5 is getting printed here, right, with a space. And then the rest 2 arguments will be the list. So this will again call itself recursively, and the first argument will go to here, and the rest will be here, right? So hello will go to T, and then A will go to args again, right? The first one will be printed here, so hello will be printed, and here now this print function, this args list will be having only one argument, A, right? So now if it is having only one argument, in that case it will not call this one, it will call the base function here. And here we are just printing the T, right? One variable will come to here. So we are printing this A, and we are doing nothing. So it means this recursive call will get terminated, and after this we have nothing, right? So it will come out from the recursive call stack. right? So this is how these numbers are getting printed, right? And similarly this one. So here we have two more numbers, but that is fine because we are using the variadic templates here. So here we are not taking care of any data type, any number of arguments like count. We are not taking care any. We are not taking care of any data types, right? We are not taking care of any initialization. All these taken care by the compiler itself, right? So I hope it is clear. Now what I will do, I will take a simple example, right? And I will show you how the compiler is doing, what the compiler is doing behind the scenes, right? So I have taken care of, I have taken this base function here, sum, right? I have taken this templated function, right? Variadic template. And then this is our main functions. From main, we are calling sum with 4 arguments, right? And in sum, what we are doing, first plus the sum again, right? We are basically adding itself. All the arguments we are summing up, correct? And then we are returning, and that return we are printing here, right? So what we can do, I can generate an assembly file. Let me generate the assembly file g++. So this assembly file got generated, this one 02vt expansion.s, right? And let me generate a dump file also. This also got generated, right? So let me first show you the dump file. So here let's go to main function. Let me search main. This is main function, and from here in main function you will see sum, right, which is getting called with 4 arguments. See, templated function and 4 arguments. And you see here this templated is getting added by the compiler itself. Here we are not in the main function. We are not we are not explicitly calling the function with templated arguments. No, we are not adding anything here, right? Because in C++, the compiler will add the data types for which it is getting called templated function, right? That is what I have explained in the templated session. Here you will see the compiler is getting added this data types, right, and the arguments we are passing, right? Now let's go to the function call here. So here we are calling, right? See, here we are calling with 4 arguments, you will notice, and here you will see this is our functions. So first argument will go to the t, right, and the rest 3 arguments will go to the list in the args, right? That is what I have explained. The first argument from this list will go to the first, and the rest argument will go to the args list here, right? That is what it is happening here. This one, 3 arguments as a list will go to args, right, and the first one will go to the first one t. Again it will call the sum recursively with the 3 arguments. Earlier it was calling with 4 arguments, right? See here in main it is calling the this one, right, 4, but now this time it is calling 3, right, 3. Now go to the next call. So here first one is coming to t, and the rest 2 will be stored as a args, right, as a list, this one, and this will again call with 2, right, this 2. And here so let's go to this definition of this one. See here, first one will go to the t, and the rest that will be 1 only, so that will be stored as a args, right? And again this one it will call this one, right? And this one, if we go to the next one here, see this one. So t only one element, and that will be returned, this return value last, correct? Here if there will be 1, then this function will be getting called and it will return the last. That is what it is mentioned here. This is returned, correct? So here you can see basically we are expanding these templated functions, right, at the compile time itself, and we are having different definitions according to the number of arguments, right? It means compiler will not see this as only one function. It will see multiple functions which were getting called at the compile time, right? So in assembly also, let me show you the assembly file also. This is our assembly file. So I hope you know a little bit about assembly. So let's start from the main in the assembly. So this is the main function body, right? It starts from here, this label number, and here in from main we are calling or sum function. So this is the sum function name. Here it is mangled name, that is why you can see this one, right? And here you see sum, this one, this is called. So it is calling this one with the 4 arguments, right? And these 4 arguments, this 1 2 3 4, which we are passing here, you can see in the or C++ code, is 1 2 3 4, right? To sum as an argument we are passing, right? So this is what we are doing here, and these are stored in the memory like this way, this 0 4 8 12 and 16, because this is an integer data type, that is why 4 bytes, right? And this 4 will be stored here, then 3 will be stored here, then 2 will be stored here, and 1, and this variable name is ESP, right? This is a list of ESP, right? Where we are storing 1 2 3 4, and we are passing this list to this function here, correct? Now go to the definition of this function. So we will come here and search. So see here, this one. So the definition for this one starts from here, and here you will see uh, this. Here you will see these 3 numbers, right? 1 2 3. Yes. So these 3 numbers uh, will be passed to the next call, and the one number is getting used in addition, that is EAX, add EAX, and it is from EBP, right? So here this is stored in EBP, here it is getting stored in EBP. So basically here you will see we are passing this by value. It means there will be a separate copy will be there in here, right? Separate copy will be created here, and that is what it is happening. So here EBP will be a separate copy. So this is moved to EBP, and from EBP here you will see in EBP, if I draw, so basically it is becomes EBP again, right? It means, and in EBP it is getting copied. So this is 20, 16, 12, 8, 4, and so on and so on, right? This is a continuous memory, and at 20 number, this 4 will be at 20, then 3, then 2, right? And this 1, right? So this list is getting copied here, and here in ARGS. Now again, see here in ARGS what we will copy. So ARGS will be here we are storing an ESP also, ESP itself, right? We are getting new variable here, ESP, and here we are see here this line at 20, that will be stored at EAX, and EAX is copied to here, this one ESP at 8th position. It means this 4 will be copied at 8th position, this one here. So it will be right. So let me remove this one here, and here this 4 will be copied here, right? Then 3 will be copied to at 4th position, right? At 16th, this one. So this will be copied here, this will be copied here, and this will be copied here, right? So this is 4, then this is 3, and this is 2, and you can see here this 16 basically EX and EX to 4, right? So 16 to EX and EX to 4 ESP. This is ESP, right? ESP variable here. So these 3 variables is getting copied, and at 0, see here 12. At 12, this number is getting copied here. And now you can see this number is remaining here, and this number is getting used here. See, move EBP. This is our EBP, right? And EBP at this position, this number is getting moved to EAX, and EAX is getting used here, add, right? Here EBP to EAX, and here EAX to right, and this EAX is getting used in add here, correct? I hope it is clear, right? So now at this call, now we are calling this one with this list with 3 number only, right? So let's go to the next call here with 3 number. this is the definition for this one, right? Here, right, again with 3 number. So now here again EBP will be pushed, right? And here this list will be copied to EBP again. So let me clear this one again. So it will be like 4, 3, 2, right? So this list will be copied to EBP. Now here you will see this move function at 16th position to EX and EX to 4. So at 16th position, so whatever is there, right? So this will move to 4 here, correct? And this is 4. And then again this 12th position, what is there, that is move to EX and EX to ESP. ESP at 0th position. So this is our ESP at 0th position. So this number will move to here, that is 3, right? So new list will get created here with 3 and 4, right? 2 numbers, and that will be called that will be passed to this call, right? Next call with the 2 argument. And this number at 8th position, here you will see this one is 8 at 8th EBP. This is our EBP, and this number will be used in the addition, right? And that is what we are doing, right? Let me show you again in our C++ code. If you remember, here we are doing the addition, this one first plus, right? So this number is as a first will be stored, and it will be used in the addition with the return value, whatever we are returning from the sum, right? See here, and this EBP is EX, right? EX is used, and this EDX, this is the return value. That's what we are getting from this function call. See here, move EX, right? So we will return with EX, and this EX is moved to EDX, and EDX is used here. So these are some registers which are getting used here. I hope it is clear, right, till now. So now we are at this position where we have the list of 2 numbers only, right? So let's call the next, right? Go to next call here. So this one, right? So I'm just finding control F doing. So here this is the definition for 2 numbers. Let me clear this one also, because once we call in the definition there, this is getting moved to EBP, right? So this 3 and 4 is moved to EBP. So this is 3 and this is 4. Here you will see this is now EBP, and ESP is empty, right? Because this is a local variable and that is taken out, right? And here you will see this move function, right? You can see here EBP is getting created again, right? And all the data whatever we are getting, right, as an argument, that is pushed to EBP at this position 3 and 4. At 12 position, whatever is there, that is moved to EX, and EX is moved to ESP. It means this number, you will see this number, whatever is there at the 12th position, see 12th, this 12th position number will be moved to 0th position, this EX and EX to ESP, right? So here this 4 is moved here, 4, correct? And then we are calling again. So now in this list we have only one number, and with that one number list we are calling the sum, correct? And here this number at 8th position, this is getting used, getting moved to EX, and EX is used to addition here. I hope it is clear now, right? And with the that is return value from this sum, right? Now what we will do, we will call the function, this one here, right? Function definition with one number, and here in this function definition, in the one number, this EBP is there, right? So it will move to EBP. So here let me clear this one. This 4 will be moved to EBP, right, at 8th position here, 4, right? And here this is cleared out, and this number in this case, basically this is the definition of the termination function, right? There we are not calling anything. So here we are just returning the last one. We are doing nothing. We are just returning the value whatever we are getting, right? And that is what we are doing here. So we are just here we are getting into the EBP here, and this EBP is getting returned. See here, we are getting in EBP here, this one, this 4 number, and here that number itself we are returning again, pop, right? So this 4 will be returned, And now if we go back, right, if we go up again, so this EX is getting returned, that is moved to EDX, and EDX is in the addition. It is, so this EDX is used in the addition with the EX, right? So this 4 plus 3, right, that will be summed up. And likewise, if we go up again for this call, right, then again we are doing the addition here with the return value, right? And if we go again up, right, then again we are doing the addition here, correct? And if we go again up, then again you will see after this call, right, and we are in main now, correct? And in main we are basically this EX is getting returned, and it is passing to C out here. You can see C out, and that is getting printed here, right? So I have explained this assembly file with memory layout. I hope you have understood this one, right? So here it is clear, and you can clearly answer in the interview that templated functions are getting resolved at compile time, right? Basically expanded at compile time, and with the separate functions according to the this argument list with the number of arguments here. Now coming to the next example, so here we have seen till now the example of the function variadic functions. Now there is variadic class templates as well, right? So this is the class, printer class, and this is the syntax of the variadic template, right? It is basically taking the arbitrary number of arguments, template arguments, and this can be used with function also in the member functions, right? Here, print impl and print impl. This is the base functions with 0 argument, right? It could be 0 also. So if it is having, the list is having 1 argument, then it will call itself, and once list is empty, right? List is empty, then it will call this one, and it will do nothing, right? So this is the base function, and this is the main variable function. That's what we have seen, right? And this is one more member functions I have added here to basically calculate the size of the argument list. So that is what you can do this way: size of dot 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 and args, right? This is how you can calculate the size of the variadic template list, right? So let me run this one and .exe. So see here, 42 3.414 hello world is getting printed, right, from print impl, and from print, right, here it is used to calculate the size. So here you will see total arguments are 5, 1 1 2 3 4 5, right? That is what it is returning. So I hope it is clear. Variadic template for functions, variadic templates for classes, right, and how it is getting resolved, that is what also we have discussed. So still, if you have any query, any doubt related to variadic templates, you can comment below the video, right? You can ping me on LinkedIn also. I will try to resolve your query, your doubt, so that you can confidently answer the questions related to variadic templates in the interview. See you next time. Till then, keep learning and keep exploring.